So far, I've only covered Xilinx development boards, but many FPGA enthusiasts are familiar with a component company called Altera. In this FPGA lesson video, we will simply do an initial dive into the Altera platform. So in a sense, it's a variant of the FPGA Lessons 1 video. If you haven't seen my FPGAs Lesson 1 video yet, here's a quick diagram of the domains that are covered in this video and FPGAs Lesson 1. So this is the basic flow for developing an initial Hello World application. The right side is Xilinx and the left side is Altera. These are the domains covered by the FPGAs Lesson 1 video. You get the FPGA and HDL concepts described, and then I show you how to download, install, and set up your design. Then I go through some basics in VHDL syntax, and finally reflash our design to an Xilinx FPGA. You can see that even if you are interested in the Altera development platforms, the FPGA and HDL concept guide and the VHDL syntax will apply to you. In this video, I will cover downloading, installing, and setting up the design environment for Altera, which will be Quartus. Then we'll develop a quick design and flash it to the FPGA on an Altera development board. So this is a diagram of the design that we're going to make in our Hello World application for this video. You can see I'm using a development board called DE2155, and so this blue box is the development board itself, and this gray box is the Altera Cyclone 4 FPGA that is on the development board. The design that we're going to make inside the FPGA is going to be a simple multiplexor with two 2-bit wide inputs and a single select line and one 2-bit output to connect to green LEDs. Then we're also going to have status LEDs, which are going to simply be wired directly from our two inputs. So how this is going to be wired is we're going to have one switch go to the select line, two switches go to X, and then two more switches go to the Y input. Then we're going to have the output, which is going to go to the green LEDs, and then the status LEDs are going to go to the red LEDs. And kind of as I mentioned before, the switches are just going to connect directly to this. So these are just going to be kind of status to show what our inputs are. And so now that I got this explanation out of the way, let's just get started in setting up our design environment. So here I'm going to go through the installation of installing the design environment for Altera, which is Quartus. First you have to sign in. So go to Menu and Design Software, Quartus Prime Design Software. Download. Okay, right, so you're going to get the Lite edition, free with no license required. I'm running Windows, so I'll pick Windows. And my internet's not so great, so I'm just going to go with the manager that they supply with their downloading method. So at this point, I want to make sure I'm going to just kind of pick and choose so I don't download too much. I'm using the Cyclone 4, so I'm just going to download Cyclone 4 for now and get rid of the rest. And then in additional software, I'm just going to pick, I think, the help. I think the Quartus comes with its own programmer embedded, so I don't think you need the standalone. Yeah, so you see that the size of the download is 3.6 gigabytes, and it's going to take a while for me to download this, so I'll get back with you when it's done. Okay, so the download completed. Okay. So now I'm going to launch Quartus Lite Setup EXE. And this might take a while to get started because it's, as you can see, a 1.2 or 1.8 gigabyte file here. Next, just gonna check this. Okay. And this is going to take a while to install, so I'll get back with you when it's finished. Okay, so the installation is all finished up. I'd make sure that the USB blaster driver installation is checked here. Otherwise, you'll have to make that installation manually, and that's going to be a pain. That's if you're the development platform that you're using is going to use this tool to program the development platform that you're using, in which case my board does use this tool, so I'm definitely going to want to make sure that this is checked. Yeah, that's fine. Okay. Since we're using the free, I'm just going to say run. Okay, so we have the software opened up now. I'm just going to start a new project here. Okay. Yeah, that's fine. Okay, next. I have no idea what this does, so I'll just start with the empty project for now. This is to add existing VHDL files that you already have. So since we're starting from scratch, we won't have to add anything. This is where the development platform will vary depending on what development platform you have. As I mentioned, I have this DE2115 development platform, so I'm going to choose the FPGA options that this development platform contains. So if you have a different development platform from the one I'm using, just look at the FPGA and the model number, the device number and everything, and just make sure you select your options here. Otherwise, besides this, the rest of the tutorial will be exactly the same. You don't have to have my same development platform that I have. So my family is a Cyclone 4. Just gonna use this guy. So looks like it's this guy. And this is if you want to use other tools other than I think the default ones that are given to you. And kind of another tip is if you made a mistake on the device that you're using, just right click here and select device, and then you can reselect what FPGA you're using. Okay, so we have this project all set up. Here I'm just going to make a multiplexor with one select line, and there will just be two separate 2-bit inputs to the multiplexor with a 2-bit output. So I'm going to go new VHDL file, and it's going to be this guy. It's not under the files. I think you have to save as, so it's going to save your VHDL file here. Okay, so I'll just keep it the name of the project. So to start off, I need to set up the libraries. Library IEEE and use IEEE standard logic 1164 all. Entity, which is I think it has to be the name of this file itself. The name of the file is FPGAs Altera lesson is. So this is going to be where you list out your ports. Okay, so here's my ports. I'm just going to use the first 5 switches on my board. So switch, which is an input. This is standard logic vector. That's going to be 4 down to 0. And then I'm going to use the red LEDs. Well, I have green LEDs and I have red LEDs, so I'm just going to use the red LEDs as the input and the green LEDs as the output. So like I said, this is going to be the status of the inputs to the multiplexor. So I just need a 4-bit wide bus here. The reason why I have a 5-bit wide bus for switches is 2 for first input, 2 for second input, and a 5th for the select line. And then LDG green out. And that's a standard logic vector. And this is just going to be 1 down to 0, because this is the output of the multiplexor. And get rid of the semicolon because it's here. Now architecture behavior of FP begin. I'm not sure if I'm going to need signals for this logic, so I have a process, and that is dependent on the switch. Begin the process, end process. I also need to end the behavior. I started a process here with switch in the sensitivity list. That means that this process will start based on the switch, so if the switch changes, this process will get executed. So if switch 4 is high, then in software you might be used to using a double equal sign for if conditions, but in VHDL it's just 1. Okay, so I'm going to make a signal here to basically act as a buffer between the green LEDs and kind of this logic here. So I'll do LDG green. We'll get assigned the signal that I'm making, which I'm going to call M out. So I need to create the signal up here. So signal M out is a standard logic vector, and that's going to get assigned to the LDG green, which is why I'm going to make it also 1 down to 0. And also notice that you don't put input or output for the signals. That's because signals, they're neither inputs or outputs. They're just they're kind of variables in a sense. They're within this module. They're neither an input or an output. So now I have that signal set up, and so I'm going to take signal M out, and I'm going to assign it the input of switches 1 down to 0. So basically I'm going to take the 0th in the first switch, so that's going to be my first input. Else if S M out switches 3 down to 0, or 3 down to 2. So not sure if this makes sense, but basically it's I have 4, 3, 2, 1, 0. So this is the select switch. This is input 2. This is input 1. And then end if. I think that's it. So to compile, you can either go here, you can say start. Yes. I also need to add, I forgot, I was going to put the switch inputs to the red LEDs. What the heck is going on here? Oh yeah, obviously I don't have a condition here. For some reason I was thinking that this was already else, and then this is spelled wrong too. Okay, so you can see compilation was successful. It's one thing I forgot to do though. It's pretty important. This was something I talked about in my first lesson video, but for Xilinx, there's something called a user constraints file, which basically maps the pins on your FPGA to the peripherals on your board. And Altera has similar things. It's for it's called I think it's called a QSF file, and it does the same exact thing. It just tells Quartus, because Quartus just deals with your FPGA. It doesn't know what your development board is. So you need the QSF file to tell Quartus what switches, specifically pin-wise and LDG, or the LED, red and green LEDs. It doesn't know where those are mapped to on what pins, so let me find that for a second. Keep forgetting where that is. I have the DE2. This board is, the board that I have is directly from Altera, so I think I can find it from here. But if you got your board, if you got your development board from somewhere else, then you need to get the QSF file from that supplier that sold you that board. But in this case, Altera made the development board that I'm using, so that's why I'm looking on Altera's website. Here's it. This is the board. It usually has it on the product page. Okay, so here it is. It's just at the bottom of this page. So the Quartus setting file with pin assignments. Okay, so this is what it looks like if you expand it. And I'm just gonna explore this really quick. So if you look up SW for switches, you see it's got all these switches here. It has the 7. I have 18 switches on this board. That's why it shows all these switches. And so, and this is the pins on the FPGA that this is connected to. So what this file does is it just tells Quartus this pin is switch 0. So if the developer mentions switch 0, then that means they want to use this pin. So I'm gonna go back, save link. Okay, so now I got that. So what you need to do in order to incorporate that QSF is go to assignments, import assignments, and then grab that guy. Okay. Yeah, and now all this went question mark again because you need to compile it with this netlist in mind. We'll start over. Okay, so it compiled successfully. All that's left now is to flash it to the development board. So use program device, hardware setup. I don't know why it's not appearing here. Here you should be seeing the USB blaster. I think I know how to. I think I know how to fix this though. Device manager. Okay, so you can see in other devices it has USB blaster here unknown. That's really annoying because I thought when I installed the drivers that this would have been solved. Just right click on that, update the driver, browse, It should be in the installation for Altera. Quartus drivers. And you can see the USB blaster folders here, so it should find it on its own. Okay, so it found it, and now it's going to install the driver. Okay, so this should work now. And now it's included in your kind of known driver list. Okay, so now it's found it. Pick it here. So it should appear here. And I'm not really sure why, but you need JTAG selected for this USB blaster device. It certainly doesn't seem like it's a JTAG connection, but it is in fact a JTAG. So it should be in the output. Okay, so here's your SOF file. That's what you use to flash. So grab that guy. I think I'm all set. So just hit start. Okay. Okay, for some reason it worked the second time. And so now I'm just going to take you to the board so you can see if it works or not. Okay, so I got the program flashed onto the board. This might be a little hard to see. Okay, so I got it propped up. And so as I mentioned, these bottom 5 switches, this one's going to be a select line, and these two are going to be input 1 and input 2. Right now the select line is low, and I also have the green LEDs here, and then the red LEDs are on this side. So if I flip these switches, then the red LEDs will light up for the switches. But I'll make one, so it's 1, and then the other one where I'll just have both high. And so this is the select switch. So that means the multiplexor is taking this input and displaying it, that input on these green LEDs. So if I flip the select line, that takes this input instead. So I can make this low, and then that LED will go low. So now you can see with the select line here, these green LEDs will match these red ones. And no matter what I do on this side, nothing will happen. But if I flipped the select line, then this input passes through the multiplexor. Okay, so that's kind of the hello world tutorial of this Altera board. I hope this video is pretty useful for you. Take care.